Hello and welcome back. We are going to go through the notes today for chapter 4D. So we are going to begin with redefining the principal in terms of a loan. So in terms of a loan, the principal refers to the total amount of the loan. So usually we use the term principal to refer to the initial deposit when we were doing investments. But when we're talking about loans, the principal is the amount of the loan, or the amount of money that you owe is another way to think about that. So the loan term is going to be defined as the time you have to pay back the loan. In full. So pay back the entire loan. All right, I'll go over the formula first really fast. So the formula for loans is we are actually looking for the payments. Previously, we were always looking for the accumulated balance, but the loan formula is actually set up for you to be able to find your monthly payments. So that's why it's set up with PMT equals instead of A. So if you notice, there is no A, there is no accumulated balance. We are just looking for how much we're paying every month on our loan. So other than that, all the letters generally represent the same things. P is your principal of the starting loan principal. PMT is still for payment. APR is still the percentage rate. N, number of payment periods, and T is number of years. And generally, when we're talking about loan payments, we usually do monthly. You usually pay back a loan every month. It's pretty standard. All right, so let's go ahead and move into the first example. So suppose you have a student loan totaling $7,500 when you graduate from college. The interest rate is 9% and the loan term is 10 years. What are your monthly payments? So again, I'm going to start this off by setting up what the letters are going to be. So the $7,500 is going to be our principal. The APR is going to be 9%. The time is going to be 10 years. And our N is going to be 12. And then also remember, when we're doing APR, we're going to change that percentage into a decimal. So we have 0.09. So now I'm just going to go ahead and fill in from this formula. So the formula, I'll copy it down here. We have payment equals P times APR over N divided by big bracket 1 minus parentheses 1 plus APR over N to the negative NT close bracket. So filling in this formula with our numbers, we get 7,500 multiplied by 0.09 divided by 12, and then the big divides bar, bracket 1 minus 1 plus 0.09 over 12 to the power of negative, it's going to be N times T, which is going to be the 12 times the 10, which is going to be 120. So I'm just going to kind of make that into one step. And then you can put this into your calculator. You can break it down into steps, but you should be getting $95 once you put that into a calculator. So that is the first example for the loan payment. All right, so next, we're gonna do another student loan example. This one reads, suppose you have a student loan totaling to $9,000 when you graduate from college. If the interest rate is 7.5% and the loan term is 10 years, the first thing we want to figure out is what are our monthly payments. And again, we're going to use the same formula. So it's going to be, let's assign the letters. So P is 9,000, APR is 0.075, T is 10, and N is still 12 because we're making monthly payments. So our monthly payments are going to be PMT is equal to 9,000 multiplied by APR over N, which is 0.075 divided by 12. And then a big divides bar, a big bracket, 1 minus parentheses 1 plus 0.075 divided by 12, close parentheses, and then it's to the power of negative NT, which is 12 times 10, so negative 120. All right, and then if you wanted to simplify this, one more step before you put this big boy into your calculator, you could do 0.075 divided by 12, just to make this look a little nicer. It's 0.00625. And then that just simplifies your equation a little bit. So you could put that into your calculator. That might be a little simpler, but either way, you should get $106.83 for your monthly payments once you put that into your calculator. So the next question is, how much will you end up paying total? So we know we're paying $106.83 per month. We know we're paying this every single month, and we know we're going to pay this for 10 years. So how we find out how much we're paying total is by doing 106.83 multiplied by 12, because we pay every single month, and then we multiply by 10 because we pay for 10 years. And when you put that into your calculator, you should get $12,819.60. Let me sign. All right. And now it wants to know how much we have paid in interest alone. So we know we paid a total of $12,819.60. But we also know our initial loan was only for $9,000. So we paid $12,819.60, subtract how much you pulled out a loan for, which was $9,000. So that is equal to $3,819.60. So that's only how much we paid in interest alone. Okay. So monthly we paid $106.83. In total we paid the $12,819.60. And in interest alone we paid $3,819.60. All right. So the next problem is the same strategy. So if you would like to go ahead and pause the video and try this next example on your own, I encourage you to do so. Or you can stick with me. I'm going to go ahead and go through how to solve this one as well. So our monthly payments, we set up our letters. So we have So we have P is equal to 8,500. APR is equal to 0.08. The loan term is 10 years, and we are still making monthly payments. So our N is still 12. All right. So then we need to figure out how we're going to fill in this formula. So we have PMT is going to be equal to 8,500 times 0.08 divided by 12, all divided by, big bracket, 1 minus, parentheses, 1 plus, 0.08 divided by 12 to the power of negative NT, so negative 12 times 10 is negative 120. Okay. And again, y'all could break this down an additional step where you do the 0.08 divided by 12 and you see what that gets you. And then keep simplifying this so it's not as bad to put into your calculator. So go ahead and practice putting this in your calculator and make sure that you are getting the correct answer. So you should be getting $103.13 for monthly payments. Now we need to figure out how much we're going to be paying total. So we pay $103.13. We pay that for 12 months, and we pay that over the course of 10 years. So when you multiply all of that together, you should be getting $12,375.60. And then the next question is, how much are we going to be paying in interest alone? And again, for that, we're going to use the same strategy. So we're ending up paying total $12,375.60. And similarly to how we did in the previous example, we are going to subtract our principal amount, which was $8,500. And that's going to get us $3,875.60. Okay. All right. So moving on to the next problem. The next example is a comparison of loans. So you would use this if you were trying to buy a car and they're giving you different options on your loan prices. So the first bank is going to offer a 3-year loan at 8%. The second one is going to offer a 4-year loan at 9%. The third one is going to offer a 5-year loan at 10%. So what we're going to do is we are going to fill out this table with our monthly payments, our total owed, and our interest payments. I'm going to show my work down here at the bottom of the table, but let's go ahead and just start with the 3-year loan offer. So for 3 years, we're going to fill in our formula as PMT is going to be equal to the because our principal for each loan is $6,000. So also on all of these, you could write P equals 6,000. I think I forgot to say that, sorry. All right. And since we're doing monthly payments, our N is also 12 for each loan offer, for loan 1, loan 2, and loan 3. So, all right. So now that we have all of our letters, we can keep going. So now we're going to do 6,000 multiplied by 0.08 divided by 12. Big divides bar, and then we have bracket 1 minus parentheses 1 plus 0.08 divided by 12 to the power of negative 12 times 3 for that negative nt. When you put this into your calculator, you should be getting $188.02. So that makes our payment for the first column 188.02. And then for the total that you're going to have to pay over the course of the loan, you are again going to do the 188.02 times 12 because you're paying it every month. And then you're also going to multiply by 3 because you're going to pay it over the course of 3 years. And when you put that into your calculator, you should get $6,768.72. What you're going to be owing in interest is going to be the $6,768.72 minus 6,000. So that gets you to a total of $768.72 that you will owe in interest. And then we're going to use the exact same strategy for the next 2 columns to find the 4-year and the 5-year loan. So, if y'all want to press pause and try it on your own, go ahead and do so, or you can keep following along with me. I'm going to move forward with filling out the 4-year payment option. So we'll have PMT is equal to 6,000 multiplied by 0.09 over 12 divided by bracket 1 minus parentheses 1 plus 0.09 over 12 to the negative 12 times 4. When you put that into your calculator, you should be getting $149.31. So this was for the loan that was APR of 0.09, and over the course of 4 years, we got $149.31. So then to find the total amount that you are going to owe, you are going to do the 149.31 times 12 because you're paying every month, multiplied by 4 because you're paying for 4 years, and that is going to be equal to 7,166.88. All right. Finally, we're going to find how much interest we are going to owe. So that is going to be where we subtract 7,166.88 minus our principal value, which was the 6,000, and you get $1,166.88. All right, so that showed us that even though our monthly payments are lower, we are going to end up owing more money in the end of the day. And finally, we are going to find the 5-year loan. So it's going to be a 5-year with an APR of 0.1. So setting that up, we'll have PMT is equal to 6,000 multiplied by 0.1 over 12. Big divides bar, big bracket, 1 minus parentheses 1 plus 0.1 over 12 to the power of negative 12 times 5, because this is the 5-year plan. Once you put that into your calculator, you should get $127.48. So that's going to go up here. All right. And then again, to find the total owed, we are going to do 127.48 multiplied by 12 multiplied by 5, because this was the 5-year loan option. And that is going to get us $7,648.80. The last thing that we need to do is subtract. So we are going to subtract the 7,648.80 minus the 6,000, because that was our principal loan. And you get a total of $1,648.80. So all we're doing here in this problem is comparing our loan options. So even though in the first option you have to pay more every single month, you end up having to pay less over the course of the loan. And then with the 5-year option, your monthly payments are significantly lower, but you end up owing almost $1,000 more than if you would have been able to pay it off in 3 years. So you pay more money in the long run with these, even though they're smaller monthly payments. So that was the goal of this problem. So we can now move on to the next one. The next one reads, you have a credit card balance of $2,300 with an annual interest rate of 21%. You decide to pay your balance off in 1 year. How much will you need to pay each month? And did you notice anything odd about that interest rate? So let's go ahead and practice again, plugging this into the formula. So the formula is going to be the same. So we'll assign our letters first, per usual. So P is 2,300, APR is 21%, so 0.21. Our time is a year, and our N is going to be 12. So I'm going to go ahead and plug this into our payment formula. So we have PMT is going to be equal to 2,300 multiplied by 0.21 divided by 12. And then the big divides bar. And we have 1 minus parentheses 1 plus 0.21 divided by 12. And then to the power of negative nt, since t is just 1, we can just have negative 12 there. All right. And again, you can simplify this as much as you want to, or you can just try to go ahead and plug this straight into your calculator. I generally like to do the little fractions first if you're going to simplify them. So simplify 0.21 over 12. However, if you decided to just plug this straight into your calculator, what you should get is $214.16. So that is how much you would have to pay every single month in order to pay this credit card off in 1 year. And then the thing that's odd about that interest rate is it's extremely high even for a credit card. So 21% is a very high interest rate. If we're, used to doing the investments and stuff where we have our interest rate, it's like 5% or 8%. But to have a 21% interest rate, even on a credit card, is extremely high for an interest rate. All right, moving on. You got into some credit card trouble. You now have a balance of $9,500 on your credit card and you lost your job. Your credit card company charges an interest rate of APR equals 21% and it's compounded daily. Suppose the credit card company allows you to suspend your payments until you find a new job. However, you will be charged interest. If it takes you 1 year to find a new job, how much will your balance be after 1 year? All right, so for this problem, what we need to note is we're not making any payments. So it's almost a trick problem. This isn't a loan payment problem. This is actually a compound interest problem in disguise. So all we're really noticing is there's a balance of $9,500. It's being compounded daily, and we have an interest rate of 21%. So we can actually use the formula for from 4B, which is A equals P times 1 plus APR over N to the power of NT. And we are compounding. We know that because we're compounding daily, that's how we know we're using this formula and not just the normal compounding formula or the other one, because we're compounding daily. So our principal is going to be the $9,500 because that's how much we owe, and that's what's gaining interest. And then my APR is the 21%, so we can write that as 0.21. The time is just 1 year because it says it takes you 1 year to find a new job. So that means time is 1 year that you're not paying off this credit card and it's gaining interest. And then N is how many times we're compounding per year. So since we're compounding daily, the N is going to be 365 because there are 365 days in a year. Okay, so now we can plug directly into the formula. So we get A equals 9,500 multiplied by 1 plus 0.21 divided by 365 to the power of NT, which is 365 multiplied by 1. Putting this into your calculator, you should get $11,719.23. So the interest that you are gaining in 1 year is around 2,200 because you only owed that 95 and now you owe 11,000. So to go from 9,000 to 11,000, that's a large increase. So that is how to find out if you defer a loan or a credit card, how much you'll end up owing after that defer has ended. All right, you guys, we are going to call this the end of chapter 4D. This was part 1. So for part 2, I'm going to cover the mortgages. It is going to take a while to get through the mortgage section, so we'll do it in a whole separate video. So we'll call this the end of 4D part 1, credit cards and loans, and then just tune back into 4D part 2 when the next video is posted. Thank y'all and have a wonderful day.